Okay, welcome to Mr. Wojcicki's Stoichiometry lectures. This is section 11, percentage yield. Okay, so some definitions first. Theoretical yield. Theoretical yield is the maximum possible amount of product obtained in the chemical reaction. So that's the answers that we've been calculating in all these stoichiometric lectures is the theoretical yield. It's in a perfect world, if everything went right, this is how much product you would produce. The actual yield is what actually happens. And the percentage yield is the ratio between those two things, expressed as a percentage. All right, so the percentage yield, why do we use this percentage? Well, we use this because it indicates the efficiency of a chemical reaction. If you're working for a major pharmaceutical company and you're making millions of metric tons of a particular chemical to distribute worldwide to 8 billion people, then the amount that you make, the closer you can get to the theoretical amount, the more your profits are. So the higher your percentage yield, the better your stocks, the better your money, the lower you can sell the medications for. It all becomes extremely important. Percentage yield is a key number. All right, so how do you calculate percentage yield? So for the reaction represented by this equation, calculate the percentage yield if 611 grams of sulfur trioxide react with excess water to produce 683 grams of sulfuric acid. So here we've got this reaction. Somebody took 611 grams in the lab of sulfur trioxide. How much sulfuric acid could they have made? Well, we don't know yet. Well, we do know that they actually made 683 grams of sulfuric acid. So is that good or bad? Well, you use your knowledge of stoichiometry to calculate how many grams they could have made. So it's a mass-to-mass problem. So you start with the 611 grams of SO3 times 1 mole of SO3 over the molar mass of SO3 times your mole ratio with sulfuric acid up top and sulfur trioxide down the bottom, so your moles of SO3 cancel. Then last step is to multiply by the molar mass of sulfuric acid over 1 mole. So theoretically, always check those units cancel. But theoretically, you could have made 749 grams of H2SO4. But how much did you really make? Well, look back to the problem. You only made 683. So imagine, in a perfect world, I could give you an exam that had 749 chemistry questions on it. That's awesome. Doesn't get any better than that for me. Just kidding. And you got 683 right. How would you figure out your grade? Well, assuming they're all worth the same amount of points, they are. 683 divided by 749 times 100 gives you 91.2%. So that's how you figure your percentage yield. It's just like calculating a grade. Okay, here's a practice problem. So you have fun with this and come back when you've got the right answer or something you think is worthy of a right answer. Okay, so we took 248 grams of chlorine, multiplied and converted it to grams of bromine by multiplying by 1 mole of chlorine over the molar mass. You get this number from the periodic table by doubling what's there because chlorine's diatomic. Then you need a mole ratio that has chlorine in the bottom and bromine up top in moles. So look at the balanced equation. In front of the chlorine, there's a 1, understood. In front of the bromine over here, there's a 1, that's understood. So your mole ratio is 1 to 1. Then the last step is multiplied by the molar mass of bromine, 159.8 grams of bromine over 1 mole of bromine. So that gives you 559 grams of bromine. But how much did you really make? Theoretically, in a perfect world, you could have made 559, but you only made 311. Oh, wow. So that's not the greatest percentage, but, as chemical reactions go, so 311 divided by 559 times 100 gives you 55%. Okay. Here's your quiz. All right, so have fun with this. Submit it virtually if that's the format we're using. If not, just write it on a piece of paper, come back for the answer. Okay, so here you took your 678 grams of methane. First step is to change it to moles of methane, because we're trying to find the grams of CO2. So we change it to moles of methane by multiplying by 1 mole of methane over the molar mass of methane. So the 16 comes from the periodic table by adding up 1 carbon and 4 hydrogens. Then you multiply by a mole ratio with CO2 in the numerator, because that's where you're trying to get to, and CH4, methane, in the denominator, because you want to cancel the moles of CH4. So look at the balanced equation. In front of methane, there is nothing. That's understood to be a 1. In front of CO2, it's also a 1. So your mole ratio is 1 to 1. And the last step is to multiply by the molar mass of your carbon dioxide. So you go to a periodic table, you take 1 carbon, and add it to 2 oxygens. So you're multiplying by 44.01 grams of carbon dioxide over 1 mole of carbon dioxide. So you got 1,859 grams of CO2. How much did you really make? We'll go back to the problem. It said to produce 1356. So you made 1,356. So find your ratio. 1,356 over 1,859 times 100 is 73.10%. Okay, so here's a homework problem. And here's the answer to it. So hide the answer, look away, and then do it and come back. Okay, so you couldn't look away. I don't blame you. All right, so you take your 200 grams of magnesium, multiply by 1 mole of magnesium over the molar mass. Now this mole ratio is wrong. You know why? Why did I put these arrows in here? Because the magnesium goes in the bottom. How silly. And the magnesium chloride goes up top. So this needs to be flipped. Now, if you made this mistake in this problem, you wouldn't know. Although if I was grading work, you'd definitely get it wrong. But since it's 1 to 1, you lucked out. All right, so the last step is to multiply by the molar mass of magnesium chloride, where you take 1 magnesium and 2 chlorines from the periodic table, add all that together, get 95.2 grams of MgCl2 over 1 mole of MgCl2. So you could have produced this is not a decimal here, I don't know what that is, but you could have produced 787 grams, but you only produced 662, so your ratio is 84.1%. Your percentage yield is 84.1%. Okay. All right, so if we had more time, I would let you go home and do these for homework. Then we go over it. This is the same problem we just went over, but then we would give you a quiz. All right, so here it is. Take the quiz, figure it out. Be careful about those mole ratios. Don't flip them. Come back when you're ready. Okay, so this problem, to find the grams of magnesium chloride that theoretically could be produced, you start with 189 grams of magnesium, multiply it by 1 mole of magnesium over 24.3 grams of magnesium. You have your mole ratio. Notice this is wrong again. The magnesium should be in the bottom and magnesium chloride should be up top. Then you multiply by the molar mass of magnesium chloride and you get 740 grams of magnesium chloride. But how much did you really make? Well, not too much here. You made 56. Look at the problem, 56.1 grams. So that's your numerator. Your denominator is the theoretical maximum yield of 740. So do the math, you made 7.58%. Okay, so that brings us to the end of this